Welcome to Scienceado Robotics. What is pick-and-place robot? Pick-and-place robots enable companies to use automated solutions for lifting objects from one location and placing them at other locations. Simple tasks such as lifting objects or moving them do not require a lot of thought processes. Therefore, using human workers on these tasks can be wasteful, as the workforce can be used for other tasks that require higher mental abilities. These repetitive tasks are handled by pick-and-place robots. These robots are often equipped with sensors and vision systems to lift objects from moving conveyor belt. Who invented pick-and-place robots? The pick-and-place robots used for monotonous tasks in the food packaging industry nowadays are based on the Delta robots. Delta robots were designed in the early 1980s by a research team led by Professor Raymond Clavel at EPFL, Switzerland. The mass-scale production of packaging pick-and-place robots started in 1987 when a Swiss company called Dimorex purchased the license to create these robots. In 1999, Flex Picker Delta robot was launched by AB Flexible Automation, which became a major game-changer in the field. The field of pick-and-place robots is still developing, with researchers optimizing these robots for picking even smaller items for computer processors, or for higher-speed repetitive tasks and precision. How do pick-and-place robots work? There are multiple designs of pick-and-place robots, based on the specific application for which they are used. The basic principle of most of these designs is on similar lines. These robots are typically mounted on a stable stand, and have a long arm that can reach their entire area of operation. The end-of-arm attachment is specialized to the type of objects the robot intends to move. These robots can transfer items from a stationary surface to a stationary surface, stationary to a moving surface, moving to a stationary surface, and moving to a moving surface, such as between two conveyor belts. How many axes do a traditional pick-and-place robot motion can occur? Simple pick-and-place robots that lift items and place them at other locations have a 5-axis robotic arm. However, there are also 6-axis robotic arms in use that can twist the items to rotate their orientation. What are the different parts of a pick-and-place robot? A pick-and-place robot has several dedicated parts, such as robot arm tool. A robotic arm, also known as a manipulator, is the extension of the robot by using cylindrical or spherical parts. Links and joints. End effector. The end effector is the accessory at the end of the robotic arm, that does the required job such as gripping objects. The end effectors can be designed to perform different functionalities based on requirements. Actuators. Actuators create the motion in the robotic arm and end effectors. The linear actuators are basically any type of motor, such as servo motor, stepper motor, or hydraulic cylinder. Sensors. You can think of sensors as the eyes of the robots. The sensors do the tasks like identifying the position of the object. Controllers. Controllers synchronize and control the movement of different actuators of a robot, thereby being the brain behind the smooth robotic operation. What are the different types of pick-and-place robots? There are many different types of pick-and-place robots, such as Cartesian robots. Cartesian robots move items in multiple planes, using x, y, and z coordinates, known as Cartesian coordinates. Fast pick robots. Fast pick robots pick items at a very high speed, which is why they are used in high-volume applications. These robots are capable of moving about 300 items per hour. Robotic arms. Robotic arms are the simplest and most common type of pick-and-place robots. As described earlier, they are used as 5-axis and 6-axis robotic arm. 6-axis robotic arm works similar to Cartesian robots but has lower positioning accuracy compared to Delta robots. Delta robots. Delta robots can pick items and place them in predefined assembly patterns or groups. These robots can be equipped with sensors or vision systems to select items based on different colors or sizes. Collaborative robots, cobot. Collaborative robots are named so because they work in collaboration with humans. Their purpose is to guide humans to the picking location or the desired location. These robots can create an optimal route to minimize transporting time. What are the advantages of a pick-and-place robot? Pick-and-place robots offer several advantages as compared to using human workers for the same purpose. Some of these advantages are: speed. The speed of operation is one of the major reasons in favor of pick-and-place robots. These machines can lift a lot of objects at the same time that it would take a human worker to lift one object. Productivity. Due to a higher speed of operation, a pick-and-place robot has higher productivity than human counterpart. This is why modern manufacturing environments are able to roll out a higher number of products, to increase production rates. Uninterrupted production. Human workers require breaks, which can lead to interruptions in the production line. Interruptions also occur during the change of shift of workers. However, robots do not require breaks and can work all day and night. Consistency. Human labor always brings in the factor of human error. However, a pick-and-place robot will work on exact mathematical principles, so there are no errors and the end result is a consistent operation. Safety. Lifting objects involves the risk factor of the object falling down on human workers and causing injuries. However, robots have no such risk, leading to higher safety in the workplace. Return on investment. Pick-and-place robots enables companies to minimize running costs by incurring a small initial investment. There are no salaries and no benefits to pay. This results in a higher return on investment in the manufacturing processes. Throughput. Pick-and-place robots result in a higher throughput as they can move a lot of objects in a given time. As mentioned earlier, fast pick robots are capable of moving items at the rate of 300 skus per hour.